Hello and good morning to our blended students. For blended students, you do really need additional practical hands-on experience. Welcome to our class today. Today we are looking at basic mapping, and it's a useful skill to have because it allows you to have an estimate of the land areas that you want to work with. Perhaps you want to make a taro plot or a plantation, banana plantation, and you want to work out how much space you need, draw a certain map of the area. Because having a map allows you to work with an area that you can see. You can sit in front of it and you can manipulate it and put your planning there and how many planting materials, for example, and so on. So that's our exercise today. Look at basic mapping. We went through the theory, we drew the map. Right to the end, we did everything. So today we are going to go through the same process, but today we are now going to put it into action. So I have in front of me here a copy of Practical 6 Basic Mapping, and I just want to read out the procedure. 1. Carefully study the area marked out for this practical. Familiarize yourself with the layout of the area. Okay, that's fine. 2. Draw a rough sketch of the area to be mapped and indicate corner labels. So today we're going to have a kind of like a four-sided figure. So it's got 4 boundary lines, kind of like a rectangular shaped area. So draw a rough sketch, indicate corner labels. So we need to put some labels on the corners. Triangulation lines, decide where they are going to go. Offsets, we're going to have 1 offset and a check line. So now we talked about the check line in the theory class, but now we have a chance to work with it. Because now we can actually measure a check line and use it later. The check line is you don't use it for a map, but you keep it separate, and then after you draw the map, then you use the same line on the map, measure it from the map, and convert it back to the field and see whether it's close to the actual distance that you measured on the map. If it's close, like different by 3 or 5 centimeters, that means it's very close. Your map is very accurate, or accurate enough. That's for you to decide how accurate you want it to be. But like I used to say, nothing is perfect. You will need to accept a certain error. But if the error is too large, like it's 2 meters, if it's different by 2 meters, then you know something is wrong, and you probably need to go back and redo it. Okay. Use the compass to indicate direction of magnetic north on one of the boundary lines, so that you can then draw the actual north line that we did in our tutorial last Monday. Okay. Use a tape measure to measure and record all horizontal distances required. So then we measure the 4 boundary line distances and the triangulation line, and the check line, and the position of the offset. So those are the ones. Use the recordings to create a map of the area. So that is then your report. Your report will consist of a map that you upload. Using a scale that will allow you to fit the map on an A4 sheet of paper. So, okay, determine true north and insert the north line. Okay, we were looking at we have a compass that I brought in class, but it didn't seem to work well. Insert the note line. Use the check line to determine and comment on the accuracy of the map. So this is one of the calculations you need to do when you finish your map. You do the check line. You do the check line and compare the accuracy and determine the accuracy of your map. That should be part of your report. Calculate the area of the map in square meters and hectares. Submit all the relevant calculations as part of your report. So that's your report is your marks you get for your report is based on that list. And those marking criteria are already on the Moodle page when you submit. It's already there. So it's just a matter of me to go in and mark them. So you make sure you cover all of these if you want all the marks. Don't cover some and not the others. So, having said all of that, let's we will go outside now, and we can start before the sun gets too hot. Okay? Yep. Outside and right in front of the agricultural engineering workshop over here, and this is I think the area can be large or it can be small, but I think today we just use a small area to illustrate what we our map practical. So let's use this rectangular shaped area here from that side, along this side, along that side. So the idea of putting the stakes on the ground was so that you can see when you're standing here, you can see where we are going to make a map of the area. Now we set the stakes so that you can see from a little bit further off. And Ken has decided that we're going to use those pins as stakes. So we are going to. Okay, can we take the stakes out, please? They're a little bit too hard to see, but since this is a small area, that's all right. So if you decide on a bigger area, you will need bigger stakes so you can see them clearly from a bit off. So let's put a stake there on that corner there, please. Let's make the area a little bit bigger. Yeah. Okay, that's our first stake. Okay, then yeah, that's enough. So that's our first corner. Ken, mayo lily. Next to the lemon tree. Put it in the shade. A little bit, Lily. Yeah. Next to the brick. No. You don't have to. You don't want to make a square. Next to the brick. Yeah. Okay. Then down here.
And then the last one there, so it's a little bit, short on this side, but we'll just have to work with this. Okay. Now that we have the stakes in the ground, we now need to label them. So I'll say that's point A. So draw the sketch now. It's a shape rectangular. That's point A. Point B, C, and D. So that's the area you need to write a map of. Yeah? So draw that into your sketch. A, B, C, D. Now, we need to put in a triangulation line. We only need one. So I think let's use now the triangulation line, of course, is dividing the area into triangles, because so the area is shaped like this. I think we'll use the BD as the triangulation line. It divides the area into triangles. The one useful thing about triangles is a triangle will keep the shape. If you didn't have a triangulation line, this shape here can be bent in different directions, and you won't be able. It'd be difficult for you to maintain the shape. But if you had a diagonal line or triangulation line, it keeps the shape. And also it's easier to draw the map like we did in the theory class. Yeah. So let's use BD as a triangulation line. Yes. Now for we need a another pin. Let's make an offset somewhere here. Just going to get another pin so that we can determine the position of an offset. So remember, an offset is a measurement of something that you want to put in the map, but not on a line. So mark the offset in there. We'll put in the measurement. This is the offset. Somewhere in the middle, somewhere in the close to the end. Okay, so let's record the measurements. So let's start from, since we started from AD. Let's start from AD and then work our way down here. So get the tape, we go over there and measure the AB line. Yeah. Oh, come here because I want you to take 3 decimal places. So right on the ground is okay. Straighten out the feet. Yeah. Okay, hold on. Okay, the first thing you do is you look at the red marks, the meter marks. So here this is what?
15,
15,
16.
16. So that's 16 meters. 6.1, 0.2, up to 0.5. And then you count the blocks. 1, 2, 3. So it's 16.5, 2, 4, 6, 8, 10. So it's 3.16.5, 3, 8. 16.5, 8. So that's up to millimeter. Yeah. So please make that recording. Yeah.
It's 16.538 meters. 16.538 meters.
8 millimeters. They all put together like it's easier to read it in like that. So we bring that zero here and we go down that way. Okay. AP is 15 or 16.538 meters. So get that end. Put your the finger there and put it down here. Come on. What's the third decimal? If it's zero, it's zero. If it's two, huh?
Zero.
Yeah.
60.
Okay, read it out again.
28.360.
38 or 28.360. 28.630.
360.
Yeah. Okay, 28.360. That's BC.
Yes.
BC. Okay. Now leave it like that. Let the tape lie on the ground, please. Slide it on the ground. We need now to use. I think it's better to determine the position of offset from here. The offset is Don't step on the tape. Don't move the tape. Maybe put something heavy on the axle. Yeah, that is a good. Slide on. Okay. Watch the tape. You don't. Okay, so. That's about how long? 4 meters, 4.5. 4.5. So let's use 4.5. Let's use 5 meters. 5 meters. 5 meters. 5. That's a 5. Yeah. So if you keep your so we are going to swing the tape arm. By another 5 meters. Okay, so we go this way. Reading on it. Yeah. 20.8 Yeah, 20.810. 20.810 is the reading on the left hand side.
810?
Yeah. Don't move the tape. 20.81. How much again?
810.
So that's the reading closer to B. Yeah. Yeah. Take. Can you
Steve.
Four.
26.
Yeah.
This is 5.
Yeah, okay. It's close enough. What is it? 26.4. Yeah, okay. 26.400. Yeah. Okay.
It's from here to
Okay. Okay. This one is the longer one.
Yes.
Okay. This reading minus that reading. Somebody do the calculations, please.
Minus this one.
Yeah. This one. Reading 2. That's reading 1. We did there. Reading 2 here. So reading 2 minus reading 1 equals 5.59 divided by 2.
2.795.
Add it to reading 1.
Add it to this one.
The reading 1. Otherwise,
To this one.
the smaller one.
23.605.
So 23.605. So that's where the perpendicular is. 23 point what?
0.605.
Come here and find 23.
Here, honestly.
23.6. 0.6. So bring a piece of stickers on. Yeah. We need to stick it in.
Stick it in.
Okay, where again? Really?
26.605.
0.605, so it's in the middle. Okay. The reason I'm putting this in is because that tape doesn't have a 0. Can you bring that tape? It's starting at what's the starting point? 10. Yeah, that's the problem. So we need this tape here to measure this from here to there. This is where the perpendicular is located. Yeah? So, yeah, let's have a look. Can you put it to the offset? This is supposed to be a right angle. Because what we did was to create a triangle like that. Find the distance down here, divided by 2, add it to that distance here. You get you get an isosceles triangle. And at the middle is the perpendicular line. And this is where we make the measurements. The true distance of line B to the offset. This is the perpendicular line from AD to the offset. So what's left now is to find the distance of the perpendicular line from there to here. And I marked the position so we can use this tape. Yeah? So take this tape and we bring the other end. Bring the zero. This is where the perpendicular is located. Yeah, bring the tape so we can measure. Something, 4.1, 4.1, 4.16, 4.1, yeah. What? 4.172 is the distance of the offset to the boundary line BC. And the distance from B to this point. Mark this point as Y and mark that point as X. Or maybe, no, let's use that. Mark this as X and that one as Y. So PX is the what is the reading that we had for the perpendicular?
23.6.
That's the one where we took the difference and added. What's it? What was it? 23.605 is the length of BX. BX is again what? BX is what again?
23.605.
23.605. What's the distance here? 4.172 is the distance of XY. XY is 4.172. You've got to make sure you are correct in those numbers because if you are not, it provides error. Okay? Yeah? Okay. So let's take the tape and measure. And then DA and then triangulation line. So please measure CD. CD, ready? This is line CD, what's the reading? 10 point something. 10.7. 8.
728.
Yeah.
Yes.
10.7 to 8. 10.7 to 8 meters. See, this is line CD. So let's measure again the last one. Yeah. And then what's the reading?
28.61.
You're getting to be
28.
an expert in make it straight up.
So it's 28.58.
5, 8,
6.
6. 28.586. That's line D8. So lay it down, please. Just lay it down. Yeah. So what we're gonna do now is to who has the compass? The compass. So come here. We'll measure the compass. Two knobs. So what's the tape? Yeah. Yeah. Okay. So we lie down.
Yeah.
Jump on the floor.
And we align it like this. So
3089.
north is in this direction. 309 degrees northwest. So the north line is pointing this. Well, it's actually magnetic north. It's pointing this way, and the angle is pointing that way. The angle is from the north line all the way up to this line.
390 degrees.
Our line here. This is our line. And the angle that's measuring here, 390 degrees, is from the north right around to the line. That angle, the angle really is from the north line here, right around, come back to the line. So the north line is, this is what you call the angle azimuth. It's the right angle. It's the angle from the north line, go in the right hand direction up to the line. So what we need to do is 360 degrees minus
409.
300. Oh yeah, yeah. But the angle that we're interested in is this one. The angle that the north line makes with our line, this one. So that angle is 360 degrees minus 309. That's 51 degrees. This angle, 309, is from the north, go right around here up to the line. It's 309. That means the angle between our line and the north is 51 degrees. 360 minus minus that angle.
360 minus the 309.
What's being shown here is the azimuth, meaning from the north,
360 minus
go around up to the line.
51.
So 390 degrees. But what we want is the angle that our line makes with the north. So that means 300, because 360 is go right. So the angle here from the line to our north is 360 minus 309. That leaves that one there. That means that's 51 degrees. So our line is pointing that way, and the north is 51 degrees that way. Now, I'm not sure whether this is pointing to the magnetic north. I don't think that's a true north. So that's magnetic north. So you need to because here in Samoa we are 13 degrees too much to the east. So 51 minus 13 degrees is what?
51 minus 30.
13.
13. 37.
37. So we need to move this way. The angle that our line makes with the true north is 38 degrees. So so that means this angle here would be 38 degrees, and you'll be looking at true north, which is there somewhere. Magnetic north is here, 13 degrees to the true north. It's just the case for Samoa. Different countries will have different, that's what you call the line of magnetic declination. So the last thing is two more things. The triangulation line B, E, A, B, E, A, B, C, D. So it's PD. So let's do that. From that stage to the other one. So remember that for triangles, which is why we're using the triangulation line, is that we're creating triangles. And triangles, once you know the three sides of the triangle, you can never change its shape. It will always maintain that shape. If you have a square or a rectangular or four-sided square and there's no triangulation line, you can change the shape anyway. You push one end and it becomes longer. But with a triangle, this is why we're using this triangulation line, you can never change the shape. It will always remain the same. Okay, read it out, please. Make it 3 decimal places. If it's 0, it's 0. Yeah, so call it out again. 34.890. 34.890. That's the triangulation line from B to D. Yeah?
890.
That's A, B, C, D.
34.892.
34.
24.
30. 34.
What is? 892.
34.890.
890.
So the remaining measurement to be made is the check line. Now, remember we said the check line, you just leave it aside, draw the map, and then you use the map to measure the check line, convert it to the actual field distance, and then compare it with your reading. That indicates to you how accurate the map is, because this reading we are not going to use to create the map. So let's go and decide what to use as the check line. So, use for our check line is the offset 2.3. Point D is there. Offset is here. The offset, you remember, was was established from this line here, using swinging the tape using line BC. So it's independent of that point. So if your map is correct, then the reading you make from here to there should be the same. So please measure. So this is offset to line to D. D. So a couple of you go and confirm.
Okay, go. 31, 32, 34, 35,
11.5.
11,
11.5.
1.
1, 2.
It's okay.
The one,
yes.
so it's 11.5, 1, whatever,
1, 2.
8. So the check line is 11.518. 11.518 is the check line. So
11.
that distance, you set it aside. You don't use it to create the map. After you create the map, and then you take your ruler, measure the offset because you already got the offset in there. Measure the offset to convert it to the field distance, which means you multiply to the scale to get the the actual field distance, and then you see you see if it's the same as the reading that you just made. So that's why it's a check line, because you're using it to check whether your map is accurate or not. If your map is accurate, it will be, this distance should be the same as the distance you got from the map. Yeah? So you need to do that and then comment on the accuracy. Do you think it's accurate enough, or because if it's not accurate, you need to go back and do it. I mean, that's the idea. But you don't have to come back and do it. You just need to comment on what went wrong. Okay, then you follow the rest of the procedures and submit it. If you have any problems or you need any advice or other things, email me. I'll be glad to provide assistance. Okay, so we've got all the measurements that we need for this particular practical. Let's go inside and determine the scale, so that each person brings in submits his report using the same scale. So let's go inside. So let's determine the scale. Let's determine the scale, because it says in the notes that you use a scale, you draw a map of the scale that will fit into an A4 paper. So here's an A4 paper. So we want to draw that map that we measured today and fit into this paper. So remember when we talked about the map in class, we said that we needed to, the best thing to do is to have a look at at the sketch. And this is why the sketch is important. So, what's AB? 16.538. BC is 28.360. Yeah, that's why I want you to sit here. Yeah. That's BC. 28.860.
360.
Oh,
360.
Oh, 360. Okay. BC.
That's BC.
Oh, okay. CD is 10.
7 to 8.
Okay, and AD is, or D,
28.
DA is 28. So which is the longest one?
DA. 28.
D8.
Yeah.
Okay. Yeah. Okay. That's
Oh, no. BD is the longest.
Yeah. Okay, that's the triangulation line. But I prefer not to use the triangulation line to determine the scale. I prefer to use an outside line, a boundary line. So BC is what again?
This is 28.260.
Yeah. And AD?
80.
So any of those two would be fine.
DA.
Yeah, 28.586. So we will use now the longest line, the boundary line, not the triangulation line, but let's use the longest boundary line to determine the scale, because if we can fit the longest line into this piece of paper, then all the others should fit. Because that's the longest one. So that when you convert using the scale, the other ones, they should also fit. So the longest line is DA, this one here, DA. Now, if we can fit DA into here somewhere, then all the other ones should fit in as well. So, well, hopefully. Okay, so we do that. And here's D. That A would be located from here, down to here. So that's A, and D would be there. So that's the, see, I made 2 marks. I said A would be here and D would be here. So we can so that's my estimate. That's my estimate. Can you hold on to it? Yeah. So let's measure it. And it is in fact 120. See, 120 millimeters. Yeah. So 120 millimeters. Now let's do the calculations. That means in the map, here, when we do the scale, is we are going to squeeze or scale down. That's why the scale says squeeze 28,586 millimeters in the field to be equal to 120 millimeters on the map. So we're going to squeeze it down, to scale it down. By how much? We can find out by dividing field distance by the map distance. Somebody do that, please.
238.
200. So that's 28,586 divided by 120. That's equal to what?
220.22.
220.
238.
Okay, 238.
0.22.
Yeah. Oh, forget about the
Point.
decimal. Excuse me. So it's 238 times. Excuse me. In other words, if we make this D8 or CD. Sorry, it's DA. If we make DA this length, then we are scaling it down to 238 times. Yeah. So that's a scale of 1 to 238. But 238 is an awkward number. Scales are usually not, numbers like that. It's either the two. They're usually multiples of 10. Now we have 2 choices. One is 1 to 200. The proper writing it is 1 238, 1 to 238 is the scale. But, you know, it's awkward. We want to make them multiples of 10. So what our two options is, because very close, 1 to 200 or 1 to 250. If we go for 1 to 200, it's going to be slightly bigger. If we go with 250, it's going to be slightly smaller, because that means you're squeezing it down more times. Yeah? So, since it's really, we have a lot of space left, I think we go for the bigger one, 1 to 200. So, instead of this one, we're going to go to scale of 1. So, we now recalculate, using this scale, we recalculate the same distance of D8. So that's dA, now using this scale. dA of, this is the field distance, dA, field. Field is what? 28,586. But now we divide by the scale that we want to use, 200. So 28,586 divided by 200. So this would be the method. What? 100 and
142.
So here you can, because these are millimeters, we can round them off. So 143. So 143 millimeters. Remember, millimeter is such a small thing that you really see. One of these divisions is a millimeter. There are 10 millimeters between 0 and 10. So this is 1 centimeter from here to here, and this is 10 millimeters. So one is one of these very small, tiny. So our new length of dA, using the scale of 1 to 200, we're going to put it here, 100, and we're going to measure it again. 143, so it's slightly longer. So here. Our old one was 120, but now it's 143 here. We can draw it in now. So this is according to our scale of 1 to 200. This is the length of dA. This is D. This is D. This is A. Yeah. There you go. And the other ones. Well, we can put in just the other three. Yeah. So what's AB? This is DA. AB.
16.
AB is 16.
0.538.
538.
Yes.
BC.
PC 28.
28.360.
360.
6. 0. So 200. What's CD?
CD 10.728.
10.728. 728. Oh, so DA, AB, BC. Okay, let's just put these in. And the diagonal triangulation line is it's a triangulation line.
This one?
Yeah.
D to B.
Yeah.
DB 34
34,
point 890.
34 point,
890.
yeah, 890. I'll turn them into millimeters. That's the 200. Okay, we need some calculations. AB 16538 divided by 200.
Oh, 83. Vamos.
Yeah, 83. Yeah. 28360 divided by 200.
28, 6.
28360
28360.
divided by 200 equals
18. It's 13.
13. 10728 divided by 200.
10,728 divided by 200. 54.
Equals 54. And 34890
34890.
divided by 200.
174.
174. So, the acres. You read them out while I I think it's 100 something, 140.
143.
Huh?
143.
43.
SDA.
So that's the one we use to determine the scale. 1, 2, 3. Yeah. So that's D. Well, that's A. And that's D down here. Okay. Yeah, we need our pair of compasses. I have one in the car. I'll go. Okay. So let's draw the map. With our ruler. Okay. So what's let's do AB. What's AB?
83.
AB
83.
80
83.
83. So we put
AB.
zero and 83.
Yeah, 83.
Yeah. That's AP.
Yeah.
Okay. The TP
174.
174. Oh, it doesn't reach. We need a bigger ruler. Bigger ruler.
No one is a ruler.
Somebody have a bigger ruler? I used to have a bigger ruler, but it broke. No?
174.
174. It's a bit low, huh? So we probably need to. Okay.
Yes.
So that's your
That's the
B.
TB.
Now we need BC.
13.
Huh?
13. 13.
That's a long side.
No, AB.
Oh, AB.
You.
We already got AB, don't we?
Oh, BC.
BC, the long one. No.
Yes.
What's that BC?
13.
It can't be. 28,000 divided by 200 is what? That's one of the longest sides.
28.6.
Yeah, 28.360.
Yeah, correct.
141. So 142. 142.
You sure?
Yes.
142. Okay. That looks so. Okay. So. Okay.
Yeah.
142. And then DC, DC
54.
54.
What's the DC?
Same. Same.
54.
Pwede mo pa. Umiyak mo rin. TC. Yung yatsu. Pwede pa PFA kilele leersi. Vai vedere in Bosnia. Non vuole farmi 16,538. Vai vedere in Bosnia. Vedi. 16,000. Kilele.
Yeah, well, remember it's very thin down there. It's not very wide. So that's I'll let you do the rest. But that's you develop the scale. Everything else now fits inside, like putting in offset. In the offset, and then you measure this line from the offset to D, convert it. When you convert it, you multiply by the scale. You multiply by 200. But this scale here would be, scale is 1 to 200. You multiply by the scale, then you compare. Then you turn it into compare. What's the check line again?
11.518.
11 check line is 11.518. Okay, so our math practical today, and let me know by email if you have any problems or you need some advice. And I will get this material and have it uploaded by early next week. So thank you and good luck to everyone. Rough tight.